This diagram maps out our agent ecosystem. Right here in the healthcare and scientific category, we see Agent 24 next to Agent 25. Agent 24 is built to apply established rules, like clinical guidelines in a hospital. But Agent 25 operates in the complete opposite direction. Its entire purpose is to search for what we don't know yet. Scientific literature is currently expanding by thousands of papers every single month. It is physically impossible for any human research team to read, synthesize, and cross-reference that volume of data. If you feed that massive corpus into a standard large language model, it acts as a summarizer. It will expertly repeat the answers that already exist. But by doing so, it completely misses the hidden connections lying between those papers. True scientific discovery doesn't come from querying what is already settled. To accelerate research, we have to engineer a system specifically designed to map out the exact places where knowledge is missing. We call those missing areas negative space. As we see in this animation, the dense clusters represent existing papers grouped by topic. The glowing void right in the middle represents a theoretical intersection between two disparate fields, a connection that should exist but hasn't been studied. You might have a specific variable, like humidity, mentioned constantly as a confounding factor in dozens of polymer-aging papers. Everyone references it, but no one has actually run an experiment to study it directly. By isolating those specific voids, the agent turns the intuitive art of scientific discovery into a structured mathematical optimization problem. It calculates exactly where experimental effort will yield a novel result. If you ask an AI to guess what's missing, it will confidently invent false narratives. To prevent that, the agent relies on a rigid, multi-stage architecture. Looking at this flowchart, the agent first scans databases and clusters retrieved abstracts. It then scans that mapped literature to find empty intersections. Next, it translates those gaps into testable hypotheses. Finally, lab measurements flow back, driving down prediction error. By feeding measured reality back into the loop, the architecture weaponizes its own incorrect guesses to incrementally close in on the actual truth. To understand how the system spots those missing intersections, we have to look past the workflow and examine the deterministic code executing the probability models. This Python script shows the core detection engine. The first function mathematically defines negative space. The second flags abandoned questions with declining publication but high citations. Finally, the code strictly ranks these gaps, scoring candidates on novelty, feasibility, and potential impact. Grounding the generation phase in these rigid, mathematically defined criteria is the only way to stop the system from proposing scientifically specious or untestable claims. The scientific discovery agent occupies a unique position. Because its primary output is a hypothesis that reaches beyond established theory, it will frequently propose ideas that are incorrect. It is, by definition, built to be productively wrong. That creates a hard boundary for the architecture. The agent produces a highly calibrated mathematical lead, but that lead demands immediate physical validation in the real world. When pharmaceutical and material science teams deploy this system, they compress what is typically a multi-year process of manual literature synthesis into a concise multi-week workflow. The agent does not confirm scientific reality. It simply ensures that human scientists spend their valuable time testing the right questions. This iterative trial and error environment works perfectly in the lab. But in our next episode, we will examine Agent 26, the financial advisory agent, where regulators strictly forbid that kind of wrong and retry logic. This scientific architecture is sourced directly from Chapter 13 of Imran Ahmad's textbook, 30 Agents Every AI Engineer Must Build.